Okay. Okay. We are live. Hello everyone. Hope the sound is good. Sorry about the camera. My light is literally in the behind the microphone. Um, I don't know what to do really. Perhaps that's better. Is that better? I don't know. Um, I can really only see the output from all of this in my. I need to get a hook here. On my OBS. So that's interesting. We're going to do what exactly? Close that. Close that. Yeah, create a new window for my web browser, I think. Yeah. Okay. Let's go. We are, as I said, we are live and we are going to do something. I have no idea what's going to happen this stream. Really, I think I'm going to write a simple virtual machine, I hope, or at least start. I've never done this. I don't even know how to begin. Um, but I guess we will see how this works. Because I don't really know machines at all, so this is a bit of an exploration, I guess. We'll perhaps start with um, something we can implement. So we need a little bit of an instruction set, perhaps. Let's call it instruction set.txt. It's going to be our okay. We're going to have a few. How are we going to what sort of how many bytes and stuff are we going to use, and all of that is going to be very dependent on how many um, how we design our instruction set. I think we're going to start with like add and subtract and halt. Um, that should probably be the add immediate, subtract immediate, and that's probably it. We're going to have it print out the result, I guess. So you need to have each instruction is going to be 2 bytes, 16 bits. Just keep it simple. I could use 1 byte, but that'd be really stupid, I think. So we're going to have 16 um 16 16 bits 16-bit instructions. So we have 16 bits. The first 4 bits nibble going to be the um going to be the opcode. Opcode. So how would that? What would that look? Op. We have oh, sorry about that. That's actually There we go. So we have oops. 1, 2, 3, 4. 1, 2, 3, 4. DW. So this is the opcode. Op. And then we have to be able to split the if you're going to do maths, we have to have be able to split this somehow, and splitting his nibbles as it's not going to work really here. So we're going to first off let's just have this is the normal. The opcode here is no op, basically. No op. And first and the prep halt. Let's make this halt. The next one is going to be, let's say, it's a nop. It's going to be that, I guess. Add immediate. This is where it's going to be interesting, because the first piece here is going to be op. No, not operand. The first operand. I1, then I2, perhaps. Call them input value 1 and 2. I'm going to create, and that's and then we're going to store that somewhere. Let's make this add I. Sub I. And we're going to store that somewhere in a register. So how many registers are we going to have? We could use something from registers. Registers. We can have A, B, and C. Two input registers and one output registers, perhaps. Or O, perhaps called O. I have no idea. I'm not a CPU programmer. Oops. So that's probably the. So we're going to put the output of this in like the O register, perhaps. So yeah. So that's the idea for now. How are we going to do this? No idea. No fucking idea. Going to import Um, yeah, using. Hello? Is it using? Not using. Import? Use? What was using? Uh, mm, Pretty sure was using. Anyway, fuck it. I don't think it's using. I think it's using. Um, yeah, G. G. So that's it. Oh, I forgot to. I forgot to start Tmax. See if I can remember how to do this. Yeah, that's correct. And in here, we are going to have the CD build. And yeah. So yeah. Hello world. Yeah, that works so far. So we're going to have to read a file. You can probably just write a file to begin with. So we have some way of knowing what to do. I'm going to do that. I'm going to need to build an assembler first. That was something I didn't hope to do. Oh well. Let's hmm. Let's actually just write a text file. Not a text file, but a hex file, sort of. So ghex. Hex. Isn't ghex installed? How's this installed? It's a flat hub. Ew. Um. org.gnome.ghex. Ghex. Test.bin. Oh yeah. That's gonna be a problem, I guess. But I have to touch that first. Test.bin. So first things first, eh? We're going to have what was it? To write her. You have a calculator, perhaps. Oops. First off, opcodes. You're not going to start with a whole. You start with an add. Two adds. We do add 1 plus 2. Put that in a register. And then subtract. So that's going to go into the O register independent. Probably more registers later, but let's just start with 3 registers, I guess. They're going to be 16 bits each register. Anyway, so this is going to be interesting because we can never actually use 16 bits, I guess, but we will see. We will see. Okay, can I get this in? Oh, let's see here. Octal. I'm going to have start with an 0, 0. Oh, hello. 0, 0, 0, 0. So the first bit here. This is the first nibble. So that's going to be 1, I guess. Right. How will that look? It's an 8. There's an easier way to do this. I should just output a file instead. You can't do that in Vala because Vala doesn't have support for that. Fuck. It's a hard one because Vala doesn't have support for binary binary string mod of string stuff, print strings and read strings. I don't really know why I can't type here. Now, does that actually work now? So 2. Then we're going to have 2 values. We have 1 and 2. So first value is going to be, I guess, 0, 0, 0, 0, 0, 1. No, but this is still. The problem is this is hex and not das. This is not correct at all. Mm. That's the first nibble. Okay, you now I understand. Mm. There's that. Oops. And then we should have 0, 0. Now then, we should split this. It's gonna be okay. First bit. That's a nibble. You have 3 nibbles. No, not really. Yeah, we had 3 nibbles. This is wrong for some reason, I think. Yeah, it should be 1, 0, 1, 0. Yeah, that's correct. 1, 0. And then now we have the first bit there. Can I change this to use bit instead? Um, hmm. There we go. Perhaps I can do that. Probably just type it out here. 0001. The 01, and then 00, 01. Is that 16 bits? It is. I think. Well, it looks like 16 bits. At least. No paste. Thank you very much. Why can't I paste here? No, okay, fuck it. I don't know what it does that, but it's not correct. Why can't I edit here? I don't get it. Why can't I edit these values here? What's the hexadecimal for this one? 1041. 10. Is that correct? That is correct. So let's see if we can do something with that shave as place. Hmm. That's interesting. Yeah, that's correct. That's weird. How do you do that? How do you do that? So this should put. Should put it in a. First comes the up code. Problem is I don't know what it actually looks like in memory. So I read everything and it's not in the right place. I don't know. I don't know. But we will see. Mm. Ten 41. 0x 1041. Um, Binary. First, we're going to I'm actually gonna have a value, I guess. Int 16 equals 0x 1041. And we're going to do what exactly? What are you complaining about? Also, oh yeah. Value. Yeah, there we go. And to shift it. So we have the mask and shift it. So the first thing is we're going to have the int 8. First int 8 is going to be equals to value and 0xf, I guess. We'll see. I don't know. It might be like that. I don't know. I don't know. I don't know. Int 16 lval lv equals value of value and wrong one. Have FC0. I'm going to shift that back 4.4. Up. Right value. Cannot convert. But it should fit. So we're not gonna. Should fit, I think. We will see. And it's gonna be 33. So this 33F. 33F. Is it gonna work? Who knows? um, let's see here. We're going to have op. Going to print it just as a number. You can look at it. Opcode is going to be OP. LV is going to be LV. Just oh yeah, forgot that. RV is going to be RV. Let's see here. Do you what's the chance that this will work then? Oh, hello. I have a little. I have. I'm not very confident that I have done this correct. Mm, yeah. That seems correct. Yes. I did something wrong, didn't I? Da, 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 da. 3F. It should be 3F, not anything else. 3F. There we go. That's incorrect. Why is that incorrect? I thought it would be 1. But I guess that is because of the bloody byte order in Big Endian. Balls. I guess. Because that's also incorrect. So the opcode is at least right. But the rest isn't. That's a mode of magnitude wrong. What did I do wrong? I thought this is 1. I shifted it to here. Right. But that should be... That's 16 bits. I need to... How many times did... Oh, did I do it wrong? I did it wrong, didn't I? I shifted it wrong. Yeah, that should be not before. It should be first 1, 2, 1. 1, 2, 3, 4. Yeah, that's correct. Sort of. Not really. Next one should be 1, 2, is 12. 12, I guess. Another same value at least. I know that works, so I'm probably in the right ballpark. But why is it? Why is it like that? So we are basically up here. Oh god. If memory is not correct, it's not laid out the way I think it is it? What does this actually look like in memory? Mm. Mm. But that is not actually what's in. Yeah. And then, oh yeah, okay. I need to do 2 less, of course. So it should be 10. Now it should be correct. Correct, right? Did I even save? Probably not. 2048. Why is the bytes in the wrong order? I feel it's bytes in the wrong order. Where are we? We are here. But that doesn't... Okay, this is a 16-bit value. Should have moved... Did I move it wrong way? Moved the wrong way. moved it. I'm thinking incorrectly, I think. Yeah, I'm moving it the wrong way. Am I not? That should be correct, perhaps. No. Let's not shift any of these. Let's just look at the values. What we get from this. Now the right value is correct. And now we need to shift the other ones 10 places. Yeah. Ah, there we go. Ta-da! I am not the smartest tool in the shed. So we can... now we have decoded the right value and the left value. It's... yeah. So that shifts everything correctly now. What's the next thing? We need to have a decoder, I guess. Decode function. Decode. It's gonna take. Let's have ops. Okay, an enum. Enum that ops. Halt add I sub I and last should be okay, I guess. I'm gonna take it up. Not gonna be a static function. Switch this case halt return. What are you talking about? That's weird. Oh yeah. I guess that's the way it should be. What do you mean? Oh yeah, I've got a... there we go. What the fuck is going on now then? Decode. Take a int 16. I'm gonna call that op. And we're going to return a right value and a left value. Right value and a left value. That is actually not correct, because we can have different yeah, because okay, this will work because I can just have different ways of doing it. Where I just use decode when I have a decode that is that doesn't have like a jump instruction, just has a value, one value. I can just use the right value or left value. Left value and right. First things first, we're going to decode the opcode opcode. And that the value is going to be op. It's actually going to be the one we return. So op, then if op equals to 0x 0x01, I guess. Yeah, 0x01. Then we're going to decode the rest of the value. It's actually going to be for many different, so we can probably use that. Use a first the L value. We have the R value. And these are going to be the op. So now then, now we can decode Um, maybe ref. L value ref. It's going to work. Out. Oh. Oh yeah. Um, case add e return d case sub e and that works. That works. That works. Works very well, I guess. Um, hmm. So we change the value to something else. Um, if we have an opcode that is 2, like 2 plus 3, 2 plus 3. It should be 2 plus 3. Why isn't it 2 plus 3? This is the wrong. What's it 2? What the fuck is that 2? Opcode shouldn't be 2. It should be 1. That should be 1. That should be 3. That should be 2. Oh, that's... FF. There we go. Because this is... Yeah, that is correct, right? FF, yeah. Now. Hmm. Minus 61. Is this 2 complement shit? Induce you instead. That's even more wrong. First nibble. You should have the first nibble. That's an F. There's nothing more than F. So that should now be correct. And it isn't. Mm-hmm. Equals 2. 2. Yes, of course it's 2. I'm dumb. Um. Right. I'm gonna need this. This has to be a switch instead. Switch. On OP. Case. Halt. Do this. Um. Why does it do that? That's better, I think. No. Closing statement found. What? Ah, there we go. Not halt. Subminute. There we go. I think. No, that's incorrect. That's not the value I put in. This is the value I put in. 1 plus 2. No, 2 plus 3. Right? So let's put that in there. Not 2 minus 3. Yeah, 2 minus 3. That's not correct at all. Two plus 2 plus 2 plus 2. That's incorrect. Two EFF. Two EFF. Two EFF. Why would that be 0? What the fuck? And up goes 15. $15. Two FFFF. Should be now. Try that. Zero. Why do we get? Yeah, because I'm. Oh, Is that it? I should move it that way, don't I? Um. Yeah, perhaps. So perhaps we need to, instead of masking first, I need to shift first and then mask. I think so. Shift 4. First we shift, and then we mask. FF. And then we do nothing of this. First we shift, and we shift that way. 10 times. And then we let's see here. What should that be? 3F, perhaps. So why is it 15? It should not be 15. Now it's 0. That's 15. That is 15. So when I filled that out, it took the last one. Huh. You do not do that. We just do that. To get 3F. 3F. We shift that one 6 places. Should get that, I guess. 0. Yes, there is 0. It is 0. $15. Why is it 15? And that's what I don't understand. Was 15? Oh yeah, forget to shift all this perhaps. I need to shift all this. But opcode needs to be shifted. Basically, how many places? 10 places. No, not 10. Why is it 10? That is 10, right? No? That is 12. That is 10. 101. 63. I want to be 63, 60, 263, 63. Not anything else. Why is it 0? I don't get it. Just lucky before. Huh? Oh. Mm. It's not even close at all. How? It should be 4,300. 4,032. 4,032. FC0. Put a 0 in front. Does this work? Why do I get 3008? That's the thing I get. How the fuck does that work? FC0. 0 FC0. 0 FC0. Hmm. Two FFF. Ah, that was correct. I think. No. Now we get problems with the masking. Yeah, now I should push everything. Okay, now the left value should be pushed um, pushed to the side 10 times. No, not 10 times, 6 times. God damn that took longer than it had to. But I still have a problem with decoding the what should I call it? The opcode. Hmm. The opcode is incorrect. First, we need to see what we need, because this is the one we need. F0000. Then we need to push it that way 12 times, I guess. Then cast it. So. Oh yeah. I'm modifying the value. Am I not? Yeah, I am. I need to copy the value before. Probably use op. If we do that, zero. Am I even? Am I even? Um, 2FFFF. 2FFFF. 2FFF. So. Hmm. Not weird. Mm, 1, 2, 3, 4. That's three. 3 times 4 is 12. So why doesn't this work? Oh. Oh yeah, I'm doing this incorrect. That is incorrect. There we go. And should be doing the masking before I do the push the. There we go. Oops. There we go. Now it should be correct. Decoding a value. Mm. First we get the values. Now we can decode at least 2 instructions. And we need to decode halt too, I guess. That's easy. Um, that's just nothing. Actually, that's probably the same as this. So Why does that not work? It does work. Okay. I'm going to decode stuff at least. Decode at least 2 values. Can probably even have this. Ops. Mm. Sabai. That should be 1777. Yes. R1. Adi. And we set it to halt, which is 0. So 0 should be halt. Halt. How do we go from here? Should probably set up the registers, I guess. And the registers are going to be just say a int 16 reg a b c b c o a b c o. So decoding. You need to put the values in registers. The registers are going to be okay. We can just case op switch on op case ops dot halt halt Addy. We heard the problem because we do expect should probably not be unsigned unless it's a address. Address should be unsigned, but value should not be unsigned. So we have to cast them, I guess. Yeah, cast them. Can even have a special operation called FFFFF. Is it called debug? And that is equals to 0x FF. No, FF 0. Yeah, that's the one. Just have to remember that we don't have that many operations now. We have. Okay, that's quite a lot anyway. So just 4,000 opcodes we can use, I guess. Yeah, 4,000. No, oh, that's 15. So we have one less. So yeah, that's 14 we can use. 14 is hopefully enough. Yeah, we could probably go with that. Um, mm, uh, print CPU. No, not print. CPU status. Yeah, CPU status. So I'm going to use a glib string builder. Hello. Add. No, append. So we're going to append the ABC registers to begin with. So we're going to print registers. Paste. And we should have that as hexadecimal, so that should probably be an F instead. Okay, let's do this instead. So we need the no, that doesn't exist yet. I really need to fix that in Vala too. So we're a half, I guess. Hatrix. Come on. Hmm. What the hell is a V? Yeah, Pandef. Pand C. I thought it wasn't a Pandef. So I see. So we need to do um um I guess this is dumb, but um fucking hell. I have no idea what just happened. My bloody um um my whole desktop just crashed. Why doesn't it? Wait, what? Okay. Um, I guess we want to recover. Possibly unassigned value. That's not correct. I'm pretty sure. Can I convert string to string will to string? Okay. Um, um, so we're going to um, have right value and left value. Basically, we're going to plus them together. Um, so that is going to be what? Exactly. We're going to have to convert them first to integers. So int 16. We need and we need to do that how? Um, to convert that somehow. I don't think this is going to work, but we'll see. LV 16 value, and then we are going to put that into O register. So reg O equals to R right value and O left value plus right value. Then we're going to print the registers. Print the registers. Just do this. It's going to be perhaps not the best thing to do, but oh well. Okay, let me think. Here we have. That's weird. Did work, did it? Oops, is halt. That's weird. Why is that? Why is that halt? The result is that's wrong. That's very wrong. That should not. That should be U8. What? It makes no sense. It did work, didn't it? Oh my god, I forgot to restart my Firefox. Uh-huh. Oops. La, 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 la. That's weird. Opcode is wrong. What? No, it isn't. Right? Um. It's weird. Why is it 4096? What is that? 95. 4095. 4095. Yeah, that's 96. But that's correct. Okay. Now it's 0. That's weird. Why is it 0? Didn't I get to fucking work? 3 times 4 is 12. 3 times 4 is 12. Must be a 0. Okay. That's why. Mm, that's weird. Oh, yeah. That's correct. That is correct. 200, 200, 126. Um, so that's correct. That is very much correct. Um, how long have I been streaming for? I've been streaming for some time. Since 17 o'clock, so that's 2 hours. 2 hours? Right. So we have decodings. First we decode and then we execute the operation. But that's really stupid, the way I'm doing it. I should really just decode the operand, decode the operand, then decode the values separately. So, and then I need to have move instructions too, moving or copying values from one register to another. So we need to have that. We need to have the a large. So we have the register version of this sub and divide the not the sub the so we have the basically add a and sub a. Uh, I think those are probably useful. So add a. It's just the same as this basically. Um, so this is this is add a add b. No, not add b. Sub a. We will basically just not to have. We just have. There's gonna be one big value. Should be one big value of this. Move register move. How do we do that? Moving values between registers. We will need to figure out how to do that. I'm going to reassign it to A, of of course. Um, yes. So, um, 1, 2, 3, 4. I'm gonna move the registers. Move stuff between registers. How do you do that in like others? Um, yeah, but how do you how what what do the IS 80 8088 8088 8088 fraction set? Just look at that. Um, this does not tell me anything. So, add. How do you determine what sort of value it is? If it's an immediate or not? That's weird. How do you determine that? Add with carry. Add. Uh, what are values on them? Immediate accumulate, immediate to register memory. How do you determine what registry and memory? That's what I don't understand. Reg memory to register, or either. Register memory with register or either. How fucking big are the instructions here? There's 32. Aren't they? Yeah, they are. 32-bit. Um, okay. So we have 3 bits to determine the. This has 3 bits to determine what register. Signed immediate. I don't want to do that. I want to do just always put out to the to register to the O register. So ABC and O. We probably need the C register can be carry register. The A register can be as a register A B carry. And the output. So we need basically have the ability to move between registers. So we need to mob R perhaps. Basically, that could also work from if the first addresses in the memory are registers. It could also work, but I don't like it. I don't like having the memory and the register in the same sort of memory pool. It seems weird to me. But I like having the subtract and add to always use the same sort of always have that and then output to in O. A result in O. So then we need to have Um, mm, Mov R, I guess. Subtract. No. Oh. But result in O. Mm, Move value in register R1 to a copy. Copy. Um, R2. I think that's going to be useful. Um, so that's basically the basic. So the absolute most basic. Um, we don't even have carry, I guess. Can I get that somehow? Even. How do we even determine if something is carrying? Oh well, let's not think about that now. Right, right, right. Um, okay. 1 0 1 0 1. Our registers are going to be 3 bits, I think. Because we really only have 4, so we can really get away with 2 bits, I guess. And the rest is going to be unused. Yeah, I think that's okay. Mm. Then we probably need to move stuff to memory. That's gonna be another fucking problem, I guess. I just don't understand how they determine if an instruction is from memory or not. Those seems weird to me. Like here. Okay, here we have add immediate. So I guess that is the output, and that is the one Red C 4-bit. Huh. Add contents of register A with register C and store it in. Okay. That's weird. Also weird. Why would he do that? No idea. It really, and then immediate. Add concept reg B with im. I guess this is signed immediate. Signed immediate, and then you put that in the other one. Mm. That's more advanced than I really want it to be. Well, it should be super easy to understand. So they just do that, I guess. They have 12-bit addresses. I think. I think I'm gonna use 16-bit addresses. No, yeah, not really 16-bit. Um, I want to be able to jump anywhere, basically. I think that's in a series you would want to jump anywhere in the registers. Have a register that has an address. You can jump to that address. The problem with that is that's really not useful, I guess, because you don't really use that. The memory is always going to be the same. I'm just thinking. First, when we load a program, it's going to be loaded into some base address, I guess. The emulator or the virtual machine is going to jump to that address and start executing. What a base value is, I don't know. And then the instructions I want to really, really. Yeah, that's going to be hard. So I can't really jump. I can't really use jumps that are. I need to offset everything with the same value, I guess. There's that. To be able to jump anywhere. How many values do we really have? This is the maximum address, I guess, I can have. Not a lot. Not a lot at all. I could use all of these. It's been more. It's been better. But yeah, these are got 4,000 bytes instructions. 4K. That is not a lot. 4K of memory. 4 kilobytes. Kibibytes. Mm. Yeah, that's how they do it here. They basically TC plus one plus immediate. I could do that, but yeah, I really have wanted to have that branch if carry, branch if out. I mean, if branch is out, branch if out, if the value um in output is positive, I guess, or equal. Yeah, that's basically the same because it's just these just two instructions instead of one instruction. That's the same basically. So a branch if equal is the same as um, is doing an add operation between A and B, I guess. I'm just going to do this another way, I think. Just don't like this at all. Um, don't like this at all. Add immediate. I'm actually going to put a register here instead. And the Register is just going to be 2 bits, I guess. And the rest here is going to be immediate value. No, it's going to be register. So register 1 and 2. Remember, the rest is going to be unused. All this is aligned. To be byte aligned, so we can unused. Those values can be anything, basically. Then we need load instruction stuff. So that's okay. Storing the O in return. Whatever is an A. Let's not do that. Let's call it im because everyone else calls it im. So that's an immediate value. Immediate value. Subtract I. No, subtract. Yes, subtract I from something that is in R1. That's probably good. Probably good. Mov R. Basically, we can the add instruction. The add I instruction can be used to store values. I guess. If we move we need a zero value. Zero register, don't we? So the zero register is going to be 0 always, I guess. 0. So, that sounds like a plan, I guess. Mm, so this is gonna be decode op. Decode op, and that's not gonna produce anything like that. We're just going to decode the so we're gonna do that. This is really going to be an int 8. Um, can we do that? Fuck it. Um, so now we need to have a decode immediate and decode registers, right? Immediate 1 and immediate 2, I guess. Yes, that should probably be correct, right? Um, really, if I do this correctly, I should probably make sure that everything that uses the same sort of logic as and it uses the same bit. Um, so I should move the subtract down. So it uses 3 instead of 2, and add immediate, submediate should probably be used the same bit too. Um, but who cares, really? Who really cares? It's not as this is like a real CPU. Um, decode op. So we have to decode um, decode registers, I guess. How many instructions? 1, 2, 3, 4, 5, 6, 7. I have 7 instructions. I could technically have done this even better, more compact, but I need more instructions anyway. So how do they pack so many instructions into this? Oh yeah, they don't have any subtract. They only have add. Ah, ah, that's smart. That's smart. That's smart. We can do the same. We can do the same. And this becomes useless. This can be moved up. Um. So we have 1, 2, 3, 4. This is not useful either because we have the other one. It's getting very compact when you don't have to deal with um, subtracting. That's interesting. Interesting. I think that it's easier to deal with nibbles anyway, so we're not gonna change it to use fewer bits. We're just gonna not use nibbles. Um, this is not subtract. No, add. Add. And it's gonna be im. Immediate value. So we're gonna have the immediate value. Add R1 to im and store in O. Move between registers. Right. That's self-explanatory, I think. Um, so then we don't need subtract. And sub I to removed. Our value is not set, of course. We don't have those values currently. We are going to have 0 registers, of course. Int 16 reg z. Zero registers should never change, so we can make that constant. That should never change. So that means we can store values by just using the I need to jump. There is one funny thing I know that is I don't remember what it was that you had a instead of branch if equals, it's skip if equal skip if 0. So if a register is 0, you just skip the next. You just push the um, you just jump the PC, the program counter. You need the program counter too. Int 16 reg PC. So yeah, program counter. The program counter is going to be have what we have. Going to have some sort of register thingamajig. PC should probably be last, I think. Should be the first one. I think the first one. So PC PC registers. If this if this was C, I would have used a union here, so that I could have these registers always be the same, and you can have an array, so you can index them. But oh well, not really gonna happen here. We can have void set reg int 8 reg. So registers. So if switch case 0 Oh shoot. Mm. Oops, undo. One, that's gonna be PC. PC. Um, so we have no, not set. Jesus Christ, that's wrong. We can't do that. So that's gonna be that's gonna be a no op. Break return is not gonna be that. PC is going to be equals to value. $16 val. And then we're gonna have break. So yeah. Guess that's okay. I have been doing this for like 3 hours now, and I haven't even come so far as to have any memory. Uh, mm, don't have any memory. Okay. I have gone through a few different iterations now, so yeah. It's I saw in another instruction set that gave me a few ideas. I don't need to have subtract and add. I just need add. It's the same as subtract, really. Um, to decode operand, then we're going to decode the values depending on operands. So we have to figure out. I guess these are the same basically, that and that. So really wanted to use basically like that, I guess. Doesn't really work, you know. Well, doesn't really matter. This isn't a real CPU. And store a result. Result in there. So add immediate. Add immediate. So what can we call these? We're gonna have basically registers. Registers. So that's decode registers, I guess. Decode op registers, something like that. That's going to return nothing, I guess. It's gonna be just gonna. We're gonna ref that. We are gonna ref that, aren't we? Yeah, we're gonna ref that. So void decode op reg1. Let's call it reg1. uint 16 op. And then we have out int 8 int 8 l r1 out int 8 r2. So now we need to do this shenanigans. So we need to mask off what we need first. So we can just define a mask, I guess. 0x0. First 4 bits are 0. Then we have the register 1. I'm not mistaken. Register 1, yeah. And then register 2. And then we need to 0 out the rest. 0. 0, 0, 0, 0. 0, 0. Do this. Nope. Right? Nope. R2 mask. RF. R0. And then we can. Then we have an immediate mask. One, two, three, four, five, six. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. M. Oh. Yeah, that's too much. How many am I? How many nibbles do we have? We have immediately we have um, immediate we have 1, 2, 3 nibbles. Okay. Should be 3 Fs. 3 zeros. There we go. That should be correct now. What? So that is those are the masks. So we have to get the opera. We have to 8. R1. Let's see here. Ba, 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 ba. Let's just call it. Do that. Up. And 1 mask. Then we're going to shift everything by 4, 8, 16, 12. I guess. Let me count. Let me count. We have the values here. We need to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10. 10. And then we need to do R2. R2 mask. And that's going to be 12. And then we assign them. R1 equals to R1. R2 equals to R2. And that should be it. So now we can decode the values. I'm gonna do the immediate one while I'm at it, I guess. So we have an op, and we decode. We don't need more than 1 here because we yeah, we're going to have the immediate value 16 im mask 16 decode im 1. Okay. Immediate mask. And then that's going to be shifted with none. We don't need to shift that at all. It should be uint. Why did I put them as integers? We're gonna do the conversion outside. Hmm. So, well, we have the we're going to have to add I. Add I. And then we have move R. That should be it, I guess. Let me just see if I can get this to work. So we need to decode. So we need to have int 16. No, int 8. Int 16. Um, int 16. That's going to be the im. We're going to store the value. Then we have the registers. Register. So we have the immediate decode op im1. Have op R1. We're going to have store 2. uint 8 R1. It's gonna be uint. It's gonna be im out as a int 16. What? I'm not defining it. I'm calling. What the fuck? Okay. So now then, now we have the values. Now we're going to have to convert them. And how do we do that? Yes, I don't want to convert them using. I really just how to do this. That's a problem. Why can I do that? No. Can't convert from U16 to 16. So we need to store its intermediate value somehow. I could just not use, because the intermediate value should always be. Yeah, let's do that. And now we need to take the value that is in one of the registers, paste, open. Get register. Return reg a. I could just let me try something. I think I can do this. I think save now is going to be going to complain. Can just do this. Um, oh, and this is going to return reg z. That's always going to be the same, so that doesn't really matter. You don't need a break. Breaks are useless when we are not going to break. $70. So now we're going to get the value of R1. So that's int16 R1 val equals 2 get reg is going to be reg, going to be R1, and then we're going to set the value of register 0. I'm going to have to make a enum reg. Then we're going to have two that value. Now we have to add that to the. So we can just do val val 16 val equals 2 R1 val plus im, and we going to set reg register is going to be reg dot o, and the val. Then we have to have a basically the same for add, but it's going to be reg 1, and the operands are going to be different because we're going to store everything as can have reg 1, reg 1, and reg 2 R2, R2, ZD, yank, paste, R2, 2, val equals 2, R2, val. No, that's correct. That's correct. That's correct. There's something else. There we go. That should now work. We can set values and add values. But we don't have any memory. But we can. I think that should work. I have no idea. I'm quite tired now. I'm streaming for like 3 hours, I think. See. I'm streaming for 3 hours and 25 minutes almost. So I'm going to stop here, I think. It's bit interesting, I guess. I'm not so sure how to. I'm not good at this programming stuff when I'm very slow at it. But I think I'm getting there. Getting back into the thinking. Because it's sort of a long time since I really sat down and programmed something other than simple applications. So I think that this is good exercise. I'm just gonna have to continue this another time. But for now, I'm going to save this. And yeah, oops. Quit all. Right? Oh, right. Quit all. Anyway, thanks for watching, everyone, and I'll see you next time.
Bye, 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 bye. Bye, 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 bye. Bye.